All right, so yesterday we started talking about our zombies, and we said that we were going to begin with 15 zombies. Each day they were going to, begin with 5 zombies, and each day they were going to turn 3 people. So we multiplied, we took our 5 and we multiplied by 3, multiplied by 3, multiplied by 3. And so this is what happened. We're taking our day, and we really didn't have anything here because one, we have to, if I can talk. Here each time, if you wanted to look, now let's see if I can write. Good. I started with 5, and here I multiplied by 3 once. Here I had 5, and I multiplied by 3 twice. Here I had 5, and I multiplied by 3 times. Here I have 5, and I multiplied by 3 how many times? 4 times. Here I started with 5, and I multiplied by 3 5 times. So if I have X days, how many times am I going to have to multiply by 5? Multiply by 3. Sorry, I'm losing it today. I start with my 5, and then I multiply by 3 how many times? This was once, this is twice, this is 3, this is 4. It would be 11 if that number right there is 11, but this says X, so it's going to be X times. Multiplying by the same number over and over and over and over is not a linear relationship. It's not the same rate every single time. What's going to happen is it's going to start off slow, and then it's going to explode. Austin, will you shut my door, please? And so yesterday, if you remember, we graphed this together. Everybody was supposed to sketch a graph. And with our graph, we saw that it was really hard to see any of the change for the first few days. But then once we really got past into the larger numbers, they just exploded very quickly. Number 3. How many zombies are turned on day 10? 295,000. What's the rest of it? 245? Yes. 245. And so what would you have to multiply this number by to get the number of zombies created on day 11? We would multiply by 3. If we were doing a pattern and we were writing, a long time ago, you guys probably talked about explicit versus recursive. Maybe you talked about explicit versus recursive. Did you ever talk about the next now or previous? Anybody remember any of that from Math 1? Little bit? Like if you have your now and multiply it by 3, that's going to give you your next number. If you have your previous number and multiply that by 3, that's going to give you where you're at now. Okay, so those are some ways that you can represent relationships. How would the entire table change if instead of starting with 5 zombies, we only started with 1? Okay. We think that it would be a lot smaller. Starting with 1 instead of 5. I'm going to write this. We think it will be a lot smaller. Everybody, you should have a calculator. When you come in this classroom, you're supposed to get a calculator. I want you to do me a favor. I want you to start with 1, and if you multiply by 1, what do you get? I need someone who's going to just give me, I guess I should just do it myself. Hopefully my calculator won't die. See if you can keep up with me. If we start with 1 and we multiply by 5, we get what? 5. Then if we multiply by 5, we get 25. That's a pretty good difference at that level, right? Then if we multiply by 5 again, we get 125. Then if we multiply by 5 again, we get 625. Is that right? Why am I multiplying by 5? What am I supposed to be multiplying by? Lord have mercy, Leslie. I'm going to get fired. Let me try again. This is 3. This is 3. This is going to be 27. This is going to be 81. This is going to be 243. Are these numbers way off? They are definitely less. Are they significantly smaller? Does anybody see the relationship? Times 3 times 3. I really thought someone in here would see the relationship.
At 9, they both go
They do. They still have a big growth at 9 and 10, right? But what do you notice about these numbers? If we're comparing 3 and 15,
Are you saying like they could?
Or you can multiply those by 5.
what about 9 and 45?
Yeah.
What about 27 and 135? So if you only start with 1 versus 5, all of my numbers are going to be divided by 5. Do you see that pattern?
Yeah.
If you're starting with 1 and you're multiplying by 3 every time, you're only changing the number, it's scaled. It's going to be scaled. So this is going to be smaller. You actually could say it is 1/5. 1/5 of the original. Now, how many of us figured out how many days it would take for us to overtake the world?
I put 20 days.
I got
20.
I got 15.
I don't know where I did it.
Yeah, we got lost. After like the 12th one, we got lost.
What number is that? Who can read that number for me?
6,975,000.
So this is thousands, this is millions, this is billions. So it is 6,975,000,000.
So if you just keep times by 3 with the 10, it said that 17, but you were a little bit off, so I'd say 18 days.
All right, so we're thinking 18. We're going to come back to that for a second. I want to look at these equations. Which one of these equations could we use to represent our number of zombies? Why the first one?
Because
Because you take the
every day you multiply by 3, and the X represents the number of days.
Okay, and so what does the 5 represent? The starting point. Perfect. The 5 represents the starting point. The 3 represents what we're multiplying by every single day. And X represents the number of days. So if we all like this equation, we are saying what happens after 17 days? Everybody's got a calculator. How could we figure it out? 5 times 3, and then you're going to use the to the 17th. Go. Calculator, what do you get? 5 times.
You get a really big number, but it's still not enough. No, you get it, but you just need like a lot more data.
Okay, I agree with Summer. Is 17 days going to be quite enough?
No.
Sometime between the 17th day and the 18th day, we are definitely going to grow up to take over the world, right? The whole world will be zombies. The whole world will be zombies. So I agree with you. This is the equation we should be using. And let's write that down. Find a well, actually, it's going to be 1, 2, 3. So this is billion. See, you're at 1,900,000,000. So that's actually bigger, right? That's actually bigger. Write this somewhere. Write this somewhere for me. We are talking about exponential. You may even want to write that. Exponential. Instead of y equals mx plus b, we should be y equals a times b to the x. A times b to the x. Where a is our starting point, or even more importantly, I'll plug in a 0. That's always going to be my y-intercept. And in this case, the b is the rate we are multiplying by. Now, in the case of the zombies overtaking everything, we're multiplying by 3, which is a number greater than 1. Anytime that number is greater than 1, if b is greater than 1, then we will see growth. We will see exponential growth. That means that function is going to shoot to the sky. What do you think is going to happen if that number is less than 1? We've heard of decay, right? Exponential decay. We actually can't have a negative as our, well, you can in certain cases, but normally our b is either going to be greater than 1 or it's going to be in between 0 and 1. If b is in between 0 and 1, decay. And that's actually like a proper fraction or a decimal between 0 and 1. 1 doesn't help us because 1 repeated 1,000 times is still 1, right? 1 times 1 times 1 times 1. That doesn't help. 0 doesn't help us because 0 times 0 times 0 times 0 is just going to be 0. So that's why I don't have the equal to there. There's no equal to. It's just between 0 and 1. What does the known variable or the unknown variable represent in our equation? What did that x represent? Y equals 5 times 3 to the x. Perfect. That's our number of days. It says, write an equation to model the pattern of instead of 12 zombies were in the sleeper cell initially, and they can infect 6 people per day. I'm going to pause that. What did you guys say up here? It is y equals 12 times 6 to the x. Anybody else got that? Y, good. Y equals 12. If you wanted to take over the world, which would be more